Hello, everyone. Welcome back. James McBride here. We're going to take a look at the surface web, the deep web, the dark web, how that compares to what the internet is. We're going to take a look at VPNs. We're going to take a look at onion routers and the onion network and Tor, basically. What is this stuff? Where can it be used? Where is it ineffective? What are we really talking about with VPNs? Does it protect you from everything that you need to be protected from? We're going to get into it right now. So before we really get started on the presentation, what I want to do is back up just a little bit to how the internet functions. So when we talk about the internet is different than the surface web, the deep web, the dark web. The internet is everything. It's made up of servers and routers, and basically your information is going between a bunch of different stuff in order to get back and forth. Now, something that we didn't really talk about is the protocol we're using, TCP/IP, is a packet switched networking protocol. And what that means is your packets flow usually from one router to the next, and you make a connection like we would see here. I know it's kind of a boring display here, but let's say you're here on this PC1 and you want to get to the internet. So you talk to your switch. The switch says, "Oh yeah, the router's over here." Now the router says, "Oh yeah, I know where that is. It's over this way, past this other router." So it sends your packets over to this router. Your packets do not enter this network because it's going to route it to its destination that's over into this network. So your packets get switched to this router, then to this router, and then finally to the machine that it needs to go to, and then the response comes back. Now, this is a very simple topology of an internet. What if we've got the real internet and you've got basically thousands of these routers? What that ends up with is multiple ways to get to the destination. In a packet switch network, basically I clicked on YouTube and now I'm going to get all these packets that are going to be flowing from YouTube to me. So we'll say that this is YouTube and this is you. Then it divides all of it up into these tiny chunks. And then those tiny chunks can go through the network how they need to. It enables the internet to be very robust. And now the downside of it is slower, but all this is happening really, really fast. So your first packet goes from this router to this router to this router, and then finally to you. Packet two, for some reason, the routers make these decisions. So for some reason, maybe it was too overloaded on this channel. So it goes down to this router, and then this router decides where to send it, and it goes to this router. That router decides where to send it, and it goes to this router, and then finally to you. So once it gets to this last router that's coming to you, these packets are put back together. So if they arrive out of order, let's say that this looks shorter, but this one is actually faster, and packet two arrives before one, there's basically a time limit that this router is holding that information and it goes, well, I got packet two, three, four, five, I'm missing one. And it waits for a certain number of time before packet one is totally timed out and presumed to be lost. And so if packet one arrives in that time frame, then it puts packet one in the front and then sends all the data to you. Again, this is all happening really fast. When we describe it, it sounds like it's slow. So if you expand this out again into this massive internet, you've got thousands of packets from your communication that are dividing up and going across this network. Now, as I said, usually it's just actually one path because that happens to be the faster path, and those paths are faster usually for more than a few seconds, right? That's like this is the better router that goes out of Phoenix, and that better router is connected to LA. And so that's usually the path that everything takes. But anyway, none of that matters. The important thing to know is that when you say, "Hi, YouTube, I would like to watch this movie," and you clicked on it, then it says, "Okay, let's start to send those packets." And those packets then may take different paths in order to get to you because the internet is all these servers and all these routers that are all interconnected. So that's how your information gets from one place to another. divided into packets. So it's important to understand that for when we get to VPNs. Now let's deal with the web. So let's deal with what does that really mean? As I mentioned a long time ago, the web is a connection of web pages. It's not the internet. The internet is much more massive than the World Wide Web. The World Wide Web is this page is connected to that page, connected to that page, connected to that page. Not all pages are connected together, right? There, you can't go onto one page that's totally unrelated to a different topic and get to this other page. We are really, really dependent on the indexing that occurs. Google has little tiny bots. They all do. Anything, any kind of search engine has a little tiny bot, and I don't mean like a robot. It's an automated little tiny program that goes and looks at different websites. So basically, that goes back down to your IP addresses that we're dealing with and protocol. So let me pull up, for instance, we use 443 for HTTPS. Let me show you that protocol as it's connected. All right, what I've gotten pulled up is just a small list of different protocols. Now, this goes back to, again, understanding that our computer systems don't use these names, right? They don't like these names. We use these, for instance, hypertext transport protocol, and that's port 80 for HTTP. We use that because it's easier for our brains to figure it out. The computers use these numbers. So basically what's happening is these bots are going out there and just hitting every IP. So they're scanning blocks and blocks of IP. We're talking about tens of thousands, hundreds of thousands of IPs. And that bot, as soon as it hits one of those and gets a response on 443, so this would be the major one that we're using. We don't really use port 80. I talked about that your browser will try to stop you from going to that, telling you it's not secure. So 443 is really what we use. And so it just goes, boom, I'm scanning hundreds of thousands of IP addresses. So if one of those IP addresses responds back to me on 443, then I know that that's open. I can now say, okay, this IP with this port number, 443, has responded to me. Now the next stage is to see what's on that. So it makes a bunch of 443 requests and basically builds a map of that website. So if you went out and started your own little website, basically that's what's happening. It just says, well, I'm scanning these all the time. Websites come up, they go down, they're there, they disappear. The World Wide Web is very dynamic. So I'm just going to scan these all the time. And then when I get a response, then I know further to go through and read the documents, to read this HTTP information, and then describe what that page is about. And that's how Amazon builds their list, or anybody builds their list. So this is all what we would call index. This bot is basically going out and searching, doesn't know what it's going to find. It's just saying, let me scan all of these IPs. Oh, these answered 443. Now let me dig in deeper, and now I'll index these pages so people can find them. That's the important part. So you do a search, and because that happened, you're able to actually find the information that you're looking for. So that's what gives those search engines such huge power, especially especially Google, because they are the one to go to. Everybody goes to Google, even though with any technology, when it first comes out, like Google was like hands down better than anybody. But usually within the next 10 years or so, everybody catches up. And that's what you find these days. You can go and search with any search engine and pretty much get the same thing that Google got. As a matter of fact, Amazon has become so huge that basically when you do a search on Amazon for a product, Google doesn't see that information, and they don't like that. These places, it's all about that information and they don't like it. So the same thing is happening on all these ports. If you're a hacker or whatever, you're going to scan all these different ports and all these hundreds of thousands, millions of servers that are out there. And when they respond off of these numbers, then you can actually go to the next step and dig deeper. And of course, many of these, like SSH, are used, Telnet is used, DNS, DHCP, they're used heavily. And so there's going to be a lot of servers that respond on those ports. Now we can move on to the next thing. We can take a look at what is the deep web. So we've got the surface web, not service, surface web, because that's indexed. That's what I just described. The deep web then is just below that. It's very much valid stuff. It's like EAC. So EAC, I've got this page pulled up, and that's coming off of my eac.edu. So that, yeah, I know there's a bunch of stuff here, right? Let's just delete all of that. Look at that. I mean, oh my goodness, so many little things it's doing here. But if I was to go to EAC site, there's a little link that says, hey, here's the portal on my EAC. So there you are. You know, I took out all everything else. It's still the same thing. This would be considered part of the deep web. This requires login. This only works when, like, I can go to faculty portal homepage, and if I'm logged in here, which I should be, it'll automatically pull up the information, right? It's logged in now because I was already logged in through this browser to EAC stuff. So when we look at, okay, well, what are we talking about here? The deep web, well, that requires login. That requires special access. And that then is part of the deep web. So really what happened is that you had the web, then the dark web got termed. That's a term for what's happening down there. And then people were like, oh, well, what about all the stuff in between? How do we describe that? Do we just say that's the web? You could, or you could actually use these terms. And these are not massive terms. It's not something that everyone actually knows, but it is becoming what we use. Often this is the deeper web instead of, you got the deep web, then the deeper. Well, what this is really talking about here is that this is all restricted information. All of this is. So when I hit that site and it logged me in, I'm accessing cloud services right there. So when you access Chase or Bank of America or whatever, you hit the surface web, you hit their main page, and then once you log in, now you're in online banking. That required a login information. You're now accessing databases that are private to them, and you can only see certain things within those databases, and that's the deep web. So pretty straightforward. That's most of the internet, as it says. And really, these are just like roughly telling you it's a big portion. Most of the web is protected by passwords. It's not just click and I can see it. Most people then want to really know, well, what is this dark web? What's really happening? Well, that gets into those protocols we were using. See, when I try to pull up, if I go back over to my page here, this is using a particular port to get this page, and that port is 443. So that could be scanned that this my EAC is there, but it's not the dark web, but it's the deep web because I got to type a password, like we said. Now, beyond that, then those pages are not indexed. So this page that you're really looking at is not part of the surface web. This hasn't been indexed because those bots can't get to it. It's protected by a login, and bots can't log in. If they could, they wouldn't. So you've got that happening. So what about this? I'm sorry, let's go back to the dark web. They're using different protocols. So you don't have to use 443 or 80 or 22 for FTP or SSH on 24, SMTP on 25. You don't have to use those. Those are the protocols that have been designed for specific functions that we do. So they're known protocols. Everybody uses them basically, even if you're not aware that you're using them. The dark web, that would be like me and you going, we really don't like the fact that the government just watches all we do. So let's take it to the utmost. Like, let's take it all the way to the other end of this. Because notice this says encrypted and anonymous. Well, aren't these encrypted? Yeah. Now they're not anonymous, but everything here is encrypted. It's encrypted. So what the heck do you mean here? Well, we're actually going to use hidden services. Those protocols tie to a service. You request a web page off of port 443. That's the HTTP service, actually HTTPS service. Give me a web page. YouTube's web page comes back to you. Amazon's web page comes back to you, whatever it happens to be. So that 443 is tied to a service, and that's what's happening here. We get together and we say, well, let's create a whole different service that's going to handle our communications back and forth. And nobody else will know what that service is. And we'll use a port that nobody else is going to know or use. And so then once we program that service, you and I can now program back and forth in this hidden service. That's what they mean, that's not normal. And now how do we find it? So if I was law enforcement and I know that somebody's doing some bad stuff, then I've got to do a lot of work to find out what's going on because they created their own service that's not easily exposed. You would have to do quite a bit. You'd have to look at the data coming off that server. So you'd have to know that server is the one they're using. Let's watch the data coming off there and then see if we can backtrack through this. Well, if it's encrypted, well, okay, we got to crack the encryption. And then we can start looking at what's really happening. It becomes very, very difficult to do. And so a lot of illegal activities happen here, but it's not totally illegal. So the dark web often is like, oh, that's the dark web, human trafficking, drug sales, selling missiles or tanks that, that are not legal to sell, this anything and everything, and that's where it got its name, right? That's dark stuff. So it's the dark web. That's dark stuff. But it also could just be people going, well, I really don't want the government knowing everything that we're talking about, so we're going to create our own little protocol. We'll talk back and forth to each other. We're not doing anything illegal. We just don't want people watching us. Now, there's some things that are part of this, and that is Tor and an Onion browser. So I'll go through the presentation in a minute, make sure I hit everything. But before we get to Tor and Onion browser, just take a look. Examples of deep web. So subscription services, medical records. And most people don't know, but your medical records are in a database that's tied to the internet. And so it's there. It could be hacked. Government databases, bunch of academic research, uh, intentionally unindexed websites. Basically, that would mean if there's government and they want to hide something, they just tell Google, don't index that, and so on. So let's take a look at VPNs and let's take a look at Tor. I think I've got, no, I guess I don't. Tor's in here someplace. We'll find it. I think it's back over here. Anyway, so VPNs. This has got a huge name, virtual private networks. And oh my goodness, people really use this all the time and they think, yeah, I'm so secure. Okay, so the thing to understand is that all of this happens in layers. Right here that we're looking at this web browser, this web browser, not that you need to know this stuff, is running as at what's called the application layer. So this web browser can see the picture that I'm looking at, right? Otherwise, it can't show it to me. That's important. So when you're using Edge, when you're using Google, when you're using all this Firefox, Safari, basically what I'm saying is those providers of that can see where you went and what you're doing. They can track it all. And Google has been very upfront saying we are tracking it all. They've been very upfront about that. Again, if you're not aware of those situations, then go over to my links that talk about especially the privacy portion and the things that they've gotten in trouble with. And then realize, okay, well, Firefox is doing the same thing, Safari is doing the same thing. Then it really becomes whether or not the company is coming forward and saying, we're not using it in this way, we won't use it in this way. So then there's that. Now we will get into some browsers that are more private that you may already be aware of, but I'll save that for the other video. So this is really the pure way to look at a VPN. When you go to work someday and you're working for a big institution, they have this main office. Then they have the server that you're going to go through to connect to the internet. Now, yeah, there's a router in here. They're not displaying the router. And sometimes this gets really, convoluted. Sometimes the router is doing this. Sometimes the server is doing a lot of what the router does. I mean, there's all sorts of ways to connect it. What you need to know is that basically there's a VPN concentrator or a VPN server. So at the main office, all this internal data is encrypted. Now we're going to shove it out onto the World Wide Web, onto the internet. We don't want people to be able to just see that stuff. So we set up this server and you're out there in your remote location and you run a little piece of software on your computer that creates this VPN. So you basically call in through this internet to this server, and the server says, oh, you've got the right protocols that you're using. Everything looks good, and what's your user ID and password, and two-factor authentication if needed. And now we have this encrypted tunnel. That's what they call it. So you're sending all your data encrypted through this, and it's a lot higher encryption usually than what you're using on a general website. It's much harder to hack that. So you're sending all that encrypted. So I wanted you to understand packet switch networks because, right, all that's still being split up. All of it's still being divided out. All the packets still have a little number associated with them. Hi, I'm packet 243 out of 500, whatever. And I went this way instead of that way. That's all readable, the IP address and the packet number. But everything else inside is all encrypted. This is very pure, typical way to look at a VPN. They were usually done for businesses. So any business, seriously, if you have any major business, we'll just use Microsoft as an example, and they have an office in Phoenix, and they have an office in Albuquerque, and they have an office in Washington, and they got an office almost in every state. Well, that's how they're going to connect. They'll connect into the main office through this encryption. And it won't be just client software here. It'll actually be the remote location because actually this is fully encrypted through here. Now, what's really happening for a user that is using a VPN service? This is different. So people will say, I'm going to connect to a VPN like NordVPN. Some of them have it built right into the browser, like Brave. You can turn on the VPN on that. And some of them actually have VPNs that they sell. So what is it really protecting you against? Well, what's happening is here's you, and you're connecting to a VPN server, and then it's connecting to the internet. Now, this is totally bogus, right? This is encrypted to the VPN. You're using your client. It's encrypted, and then here it's encrypted. However, what's really happening, and I couldn't find a picture that really displays this, is you are connected to this VPN server, and so your internet service provider, because this is an encrypted tunnel, it's encrypting what you're doing. So your internet service provider cannot see, I'm accessing Google, I'm accessing YouTube now, I'm accessing howtobuildguns.com, I'm accessing, whatever it happens to be, right? I'm accessing my bank account, I'm accessing my health records, I'm accessing, it can't see that because the client software you're running encrypted it and only sent it to this server. So that's why I wanted you to understand that there's a number and there's a port that it's using, and you can't encrypt those numbers because they have to be used in order to connect to the internet. So really what's happening in this VPN is that you are speaking directly to this server, and the internet service provider only sees that you're connected to NordVPN. Everything is going to NordVPN. Everything is. So they just see, oh, they're talking to NordVPN all the time. Then the VPN server, Nord, is then saying, I'm going to connect to the website you're asking for. And so that's not really the same thing as what we were looking at before. It's actually expanded beyond what we were looking at before. So it is, you're creating this tunnel that's encrypted, but the real privacy comes into the fact that this VPN server is actually requesting the information off of the internet. Now, remember that all this has to be tracked. So, in order for Nord to know that it's coming back to you, it knows you, this user device, wanted this internet connection to chase.com, we'll say. So it knows. That way, when the information comes back from Chase, it can send it to you. Otherwise, right, it's lost. So it really depends on your privacy, depends on whether or not Nord is going to keep that private. And yeah, it's becoming, I would say, safer to do things this way. But a lot of times they usually are tracking everything. There's been, I don't know how many that have become really popular, VPN of choice, and there's millions of people using them. And then that VPN service comes out and says, "Oh, yeah, we've been recording everything, by the way." So we actually sell that. Yeah, there's been a lot of stuff like that. There's been some very high profile cases where, say, and this did happen years ago, FBI is tracking a child pornography ring. They find this traffic coming from the VPN server to the child pornography. So that was in Germany. So the FBI goes over to Germany and says, "Hey, Germany, can you help us out with this?" The German police say, "You betcha, we'll help you out with this." So they go over to the VPN service and said, "You're looking at child porn." And they go, "No, we're not." And they're like, according to our thing, because right, we can only follow that traffic back to here. So it's you, and we're going to prosecute you. And they just said, "Oh, no, no, no. Here's all the records. These are the ones doing that." And there's a lot of laws that people don't know about. So it's one of those situations that you need to understand that you're relying on this VPN service provider to actually not track that and to not turn it over to somebody someday. So, what privacy are you really getting? Well, your internet service provider does track that, and most internet service providers will sell that information. So, they watch your computer say, "I need to talk to Amazon." And they track it and go, "You're talking to Amazon like 50% of your time." And they sell that data. So, a VPN server does make it so that they don't see that data. Now let's back up. As I said, you're running a web browser right here on this device. I'm running a web browser right here. That means Edge, which is what I'm using, knows that I'm connected to Suntico.vm. They know that I'm connected to that. And so they can collect that data if they want and sell it if they want. So you really have to think about, okay, what am I trying to do with this? VPNs do slow you down because whenever you do this really, really high encryption, which is fantastic, that's going to slow things down. So you've got that trade-off with how a VPN works. A lot of people will use a VPN to hide where they're coming from, and that's become a big deal. For instance, Netflix is worldwide. Amazon, their video service is worldwide. And so they have licenses depending on the country that they're in. And some people don't like that. Some people don't like that they bought a license to, maybe show Big Bang Theory in Brazil. But here in the US, Amazon doesn't have that. So what a person will do is they'll use a VPN server, and the big ones, right? They'll let you choose where do you want to actually connect to that VPN server. And so then they choose Brazil. And then that means this VPN server dumps them out in Brazil. And then Amazon is fooled into thinking, "Oh, you're in Brazil, so you can go ahead and watch this show." So a lot of people do that. They'll choose a VPN server from around the world because, right, that traffic is encrypted between you and that VPN in Brazil, or you and that VPN in Norway, or wherever it happens to be. So a lot of people will use it that way. But I did want you to understand, like, is that total protection? No, no, not at all. So let's take a look then at dealing with the onion router. Where's my onion router stuff? I don't know. It's someplace up here. It's not. Maybe I closed it. Maybe I closed my onion router. I think so. All right, well, let me pull up my graphic for what an onion router is doing for you, um, and and what Tor is doing. So pause it for a minute. All right, so first off, the onion router is not a dark web technology. You can use the onion router on a daily basis to just access websites because you don't want people knowing where you're going. And so you can use the onion router Tor network to get to whatever you want. And it's interesting where this came from. So basically, way back as the internet first gets going, so you're talking about the early 2000s. Um, the military realizes because it's really getting used. If you have somebody in the military, then you know they can have their own personal address, but they also get a military address that's something dot Navy dot mil, right? The MIL, and only military gets to use that. And so they're sending this communication back and forth, and they're really using the internet. And one of the admirals is like, you know what? This is all unprotected information. I think honestly, people in the service get a bad rap because movies constantly throw them under the bus and say they just want to go out and murder and kill people. And so I think, in my opinion, they get a bad rap, and they're usually people that are trying to protect everybody and want what's best for everybody. And they don't necessarily trust every avenue of the government. So this admiral basically says, okay, I'm going to put you computer techs to work. Can you find out a way to anonymize our requests so that somebody can't tell that email and where it's going to and can't just read that email? This is going to be important for us because basically the whole internet at that point is not encrypted. And, that's the heyday of hacking because you don't have to do anything. You just watch the stuff. I'm sure there was lots of people in the government that love that. And so this project comes out of this admiral, and they created the Onion router. Basically, what ends up happening is there's a whole bunch of computers out there or special devices, but normally computers. And they all say, I will be part of the Onion network. I will do that. And they contact all these other computers that are out there in that network. Then you run an Onion proxy. So nowadays, this is built into Brave. We'll show you that stuff. I'll show you, this is where you get the Onion browser if you want. But basically, you run that, and it talks to a directory server that knows where all these different computers are. And that changes dynamically. So that's really a dynamic thing. Then, because you're dealing with your packet switched IP information, not only is it going from router to router, so I know there's no router showing here, but it's also going from these computers that are part of this Tor network, this Onion router network. And so your data, right, it's showing it goes here, it goes here, it goes here, and here. Yeah, that was one packet. The next packet goes here, 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 and there. The next packet goes here, here, and there. The next packet, what I'm describing is if you use it, and I suggest you try it, honestly, there's nothing illegal in trying this, but you'll see, wow, this is a lot slower. This is so slow because it's going to take these packets and break them out into routing it through this massive, massive system of people that volunteer to do this. And then it comes out this other side. So this computer thinks, oh, I'm talking to this one for these packets. I'm talking to this one for these packets, this one for these packets. And so when it responds back through this massive maze and then gets put back together here. It's not impossible to track. Remember, you have to have these numbers that are following it. It just makes it a lot more difficult to track. We're really on the open network without a VPN and without an onion router. Big organizations, governments can just see what you're talking to and how you're talking and how long you're talking and all that. They can deal with all that. And a lot of people don't like that. So that's the Onion router. You get a browser that it's built into, or you can get a browser that has it as a part of it and you select it, you turn it on and off, that kind of thing. But it's definitely worth trying. You should note that even on the surface web, when you have that activated, you will get different search results. So, all right, let's just go through this information just really quick to make sure I covered everything. The internet is larger and more layered. We talked about that. We've talked about surface, deep, and dark. And we also talked about VPNs, legitimate uses, and so on. We already talked about this. This is the indexed portion of the web. It's usually less than 10%, but that's what we use 90% of the time. The deep web is not indexed by search engines. It's hard for them to do, right? They would index it. Oh, why aren't they indexing it by, these search engines? Because when they send their bots out, those servers are not responding on any of the ports that it would normally respond on. So they don't even know. It's like, well, I guess that server's not doing anything. That's what happens. And then we talked about paywalls, private URLs. It's not inherently secret or illegal. Like I said, you got academic databases, online banking in the deep web. That's not illegal. We don't want that stuff indexed. We don't. You don't want your bank account pages indexed. You don't want your medical information indexed so anybody can find it. As a matter of fact, that's one of the ways that hackers get things that they shouldn't, is because somebody didn't protect, say, the database the way they should, and it got indexed and they can search it. So, Tor browser requires special software. Tor browser, yeah, that's the only thing we have. But again, if you're actually saying, no, I'm going to do this really illegal stuff, then you're going to actually have to use the same protocol as the other person, which means usually they're building an app and you have to get a hold of that app in order to get into that. Yeah, it's a thing. And I would caution you not to do that thing. Some people are really curious, right? I have students that are like, well, I want to know. I don't plan on doing anything illegal, but I want to know. Well, yeah, there's websites that will have that particular piece of software that allows you to connect to these other sites that this stuff is on. So you can find it. But normally in the process, right, you have to install that software. And in the process of installing, you're hacked. And so there's no honor among thieves. The movies about honor among thieves is not true. There's no honor there. So if you're going to try to learn illegal stuff and do illegal things, then they're going to hack you and steal your money before you ever get to do that. Anyway, yeah, obscures IP addresses, circumventing censorship. That's the legitimate use. Secure communications for journalists and whistleblowers. This is very, very true. So you've had people actually at the FBI that have been whistleblowers for lots of things. And lots of people look at this as political, but the Hunter Biden laptop was a huge thing where basically FBI whistleblowers said, yeah, there's people protecting this. This actually really does exist. And some of them lost their jobs. And one of the ways they do this is to be able to report it through that privacy channel using a Tor browser or something, so it can't be easily tracked back to them. Activist researches vulnerable populations, and what they mean by that is that there's some countries that really control access to the internet, and usually that, places like China or Iran or tons of them, they filter the internet heavily and make sure that people can't report out what's happening or can't see what's happening outside in the rest of the world. And so this, Tor and other things are ways to try to circumvent that so that they can get out and report what's happening, which usually in a lot of those situations means death, which, is bad. It's bad for them. And then, of course, so the illicit stuff that we talked about, malware distribution, you can buy malware, you can't make it yourself, so you buy it, and then you release it the way you want. It's stolen data, obviously, illegal drugs, jewels, sales, But while academic study is legitimate, illegal activity obviously is not. And they want you to understand that. It's like the dark web is not illegal. What you're doing on it is probably illegal. All right, and we covered VPNs. Went through that and how they work. And limitations, the VPN provider may see the traffic and restrict and strict no log policies have to be enforced there. And they tell you, I mean, the ones that have been caught, the honest truth is they say, oh yeah, we're not tracking this. We won't keep it. And then all of a sudden you find out that they were and they were selling it. It's not good. Doesn't provide that complete anonymity and does not protect against malware or phishing. I should have mentioned that. Like that doesn't, and Tor doesn't protect against that either. Those are not protecting you from malware or phishing scams. It's protecting your identity more. Let's see, reduces ISP traffic and then geo-restricted information. And then there's our onion router. So take a look at that for details. If you have questions, let me know. If there's a lot like, oh, I know somebody and they're doing this. Is that illegal? Right? Just ask me, not a problem. You see something else, like there's a technology here that we did not talk about. Does it fit within VPN or Onion router? Is it something else? Go ahead and ask, not a problem. But yeah, that is it for the deep web, the surface web, the dark web, VPNs, and onion routing. If you're interested, take a look at the other video that, of course, is not part of the test, but is a part of this is how you set up an onion router. And these are the different browsers that are out there that say they're going to protect your privacy more. And I always throw that in, they say they do. Safari, right? Apple has been very upfront. It's like, we're not going to track you and we're not turning that data over unless they bring a subpoena. Microsoft has been pretty upfront about that too, doing basically the same thing. But of course, now they're like, hey, we got this big thing with AI, so we're going to harvest all that into AI, and that's not private. And then Google just says, hey, it's your data. It's your data. You can delete it when you want, but they don't tell you. That doesn't mean we're going to delete it from our stuff. That just means that you can delete what you see. Again, already given examples on that. So watch the next video if you're interested in those things, and we'll talk with you later. Thanks for watching.